The flying car is the oldest promise in transportation, and for 100 years it's been a graveyard. But that could change sooner than you think. However, dozens of companies have chased it and burned through more than $13 billion. Most are now bankrupt, not because their aircraft couldn't fly, but because they could. The machines worked, but the companies still collapsed. The flying was the easy part. What broke them was something else. And yet, one city has already signed a 6-year exclusive deal and started building the landing pads, betting real concrete on flights that aren't certified to happen. The idea is almost old enough to feel inevitable and seems very simple to build nowadays. Just stack a few rotors onto a small electric aircraft, take off vertically from a rooftop, skip the traffic entirely, and land on another rooftop across the city. Quieter than a helicopter, cheaper to run, and no runway. Starting around 2019, roughly $13 billion flooded into companies promising exactly that. But there was one issue. The machine that makes the pitch true is one of the hardest objects in modern engineering to actually build, and the graveyard proves it. Start with the most stubborn case. For decades, an engineer named Paul Mahler sank a personal fortune and tens of millions of dollars into a vehicle called the Sky Car. The flying car that magazines at the time kept promising was just 5 years away. But Mahler never demonstrated an untethered hover that went anywhere. The single most famous flying car of the 20th century never once flew free. That should have been a warning about how hard the physics is. Instead, the modern wave assumed electric motors and computers had changed the game. And they actually had, but not the part that matters most. A jet burns fuel as it flies, so it gets lighter the longer it stays up. A battery weighs exactly the same when it's empty as when it's full. And the energy you can pack into that fixed weight is brutally limited. A kilogram of jet fuel holds something like 12,000 watt-hours of energy. A kilogram of the best aviation battery cells holds around 250. Electric motors are far more efficient than jet engines, so they claw back part of that gap, but nowhere near all of it. The aircraft ends up carrying enormous dead weight just to move a handful of people a short distance. So every design lands in the same trap. Add more battery for range and the aircraft gets heavier, which demands more power to lift, which drains the battery faster. Strip battery out to save weight and the range collapses to a few city hops with almost no reserve. The engineers were not failing at flying. They were failing at a math problem with no comfortable answer. And sitting on top of that was a second wall, taller than the first. These machines are a brand new category of aircraft, neither plane nor helicopter, which means there was no existing rulebook to certify them against. Regulators had to write the rules and grade the homework at the same time, all while holding the aircraft to the safety standard of a commercial airliner. That standard is the 1 in a billion number, and proving it takes years of testing and hundreds of millions of dollars before you are allowed to sell one ticket. This is where the money started to die. Lilium was the German favorite, a sleek, jet-like aircraft with dozens of small ducted fans buried in its wings. It raised about $1.5 billion. It flew. It booked orders for 120 jets, and it still couldn't outrun the clock. Certification was years away, the burn rate was enormous, and in late 2024, the cash simply ran out. A rescue consortium pledged around 200 million euros to save it. The money never arrived. By February 2025, Lilium had filed for bankruptcy a second time and stopped operations for good. Volocopter, another German frontrunner with a working air taxi, filed for insolvency just months earlier, at the end of 2024. So picture the field in early 2025, $13 billion spent. Two of the most funded companies on the planet dead within weeks of each other. Working aircraft sitting in hangars with no one allowed to ride them. From the outside, it looked exactly like a bubble finishing its collapse. A decade of hype, a fleet of expensive prototypes, and not one ordinary passenger who had ever paid to fly to work. The honest question wasn't when this would arrive. It was whether it ever could. And that's the moment the story turns. While the loudest companies were burning out, one of the quietest was doing something different. Joby Aviation, based in California, had refused to outsource. It designed, built, and tested almost everything in-house: the airframe, the motors, the software, the manufacturing line. That vertical integration was slower and more expensive up front. It also meant that when the regulator asked a hard question, Joby controlled every part needed to answer it. But solving the engineering only moved the problem. Building an aircraft that flies safely is not the same as proving it to a regulator, and the FAA process is a gauntlet of stages, each harder than the last. The deepest of them, Stage 4, doesn't just ask whether the design is good, it demands that the actual hardware coming off the production line matches the certified design exactly. Every structure, every wire, every failure case logged and witnessed. It is where most of the optimism in this industry has historically gone to die. In late March 2026, Joby cleared it. The FAA confirmed Stage 4 for its aircraft, a 5-seat, 6-rotor design with tilting rotors, a roughly 200-mile-an-hour cruise, and about 150 miles of range. It was the furthest any electric air taxi had ever gotten toward a real commercial certificate. But even that win exposed the next problem. Clearing the engineering doesn't clear the rulebook or the economics. Joby had once hoped to be certified by 2025. That slipped, and final approval is now projected for late 2026 or even 2027. The bottleneck had moved. It was no longer, can this thing fly safely? It was, can the regulator and the business model move as fast as the hardware already has? And that single question is why the first commercial air taxis in the world will not fly over an American city. Dubai made a different bet. Instead of waiting for a cautious regulator to write a perfect rulebook, the city signed Joby to a 6-year exclusive agreement, built the infrastructure in parallel, and aimed straight at a 2026 commercial launch. By late 2025, Joby had already completed the first crewed point-to-point air taxi flight between 2 locations there, and crews were finishing a network of 4 vertiports, including one at Dubai International Airport. The goal was blunt and commercial: cut a brutal airport commute to a few minutes and own the market while doing it. The United States, meanwhile, chose the opposite philosophy: thorough, incremental, and slow. Then, in 2025, it changed gears. A presidential order pushed the FAA to accelerate, and by March 2026, the agency had selected 8 pilot projects spread across 26 states to begin real-world test operations, with public flights targeted for the summer. It is the largest coordinated air taxi testing effort anywhere on Earth. But notice what that means. The leading aircraft in this race was built in California, and the first city to fly it commercially at scale is in the Gulf. America is running the bigger, safer experiment. Dubai is running the faster business, and the bubble question still isn't fully closed. Even Joby needs 2 more separate approvals before a single paying passenger boards in the United States, a type certificate for the aircraft, and an entirely separate license to operate as an airline. And underneath all of it sits the original number that killed the others. Nobody has yet proven that you can price a seat like a taxi ride and still pay back a machine that cost billions to certify. What's being built right now in Dubai isn't a better rotor or a lighter battery. It's the first real test of whether the math behind the dream was ever going to work. That divide does not stop at the edge of the sky. On the ground, the same split already separates the 2 companies racing to remove the driver from the car. One expanding cautiously, one mapped service area at a time, the other holding a fleet it believes it can switch on everywhere at once. To see how a single software update could let one fleet overtake its rival overnight, click this video.